In this tutorial we will make something like this. Often we have to deal with some moving containers filled with liquid, glasses, bottles, etc. And we need this liquid to react properly to this motion. We need some inertia jiggling. Suppose some character holds this glass and does some handplay when talking. But simulating proper liquid behavior can be very expensive in terms of time, for example. In a very simple case, we don't need real splashes. We need fluid level to react properly to the glass motion without pouring out, and then to become stable in its horizontal position. And we can use a trick which will be shown further. The idea is to put dynamic curve into the bottle, jar or glass near the fluid level and parent this curve to the container geometry, and then attach fluid level surface to this curve. So when we will move this glass, hair will jiggle and so will fluid level surface. One hair will be simulated pretty fast. This is the basic glass made with revolve operation. And note that this glass should be of correct scale. Suppose you make this rig for the character, so this glass should have correct scale relative to this character. We actually will be able to scale this rig. I've tried several scales and this rig works normally if I leave original scale or if I make it larger. So always remember that if we scale this rig down, we will have some troubles. The smallest scale can cause some issues because we're going to use trimmed surfaces, and for the smallest scale, trim tolerance can be insufficient. First, let's decide where will be the fluid level. Suppose it will be here somewhere at the 1/3 of the glass volume below glass top. So let's create some dummy here, just a simple locator. Move it here. Let's freeze its transformations, and let's name this locator level controller. And let's also create quite large noobs plane. Let's scale it. Let's also increase its subdivisions, something like this. Now let's point constrain this plane to the locator. Now we need to parent this locator to the glass geometry, and let's actually create some controller, just a simple noobs circle. Let's scale it a little down, delete its history and freeze its transformations. Let's name this circle glass controller. Now let's parent this glass under this controller and also parent this level controller under glass controller too. Now if I move or rotate this glass controller, this plane is always horizontal. So this will be reference plane. And when animator will animate hand holding this glass, he should avoid intersection of this plane with the glass border. Actually, this plane can pass over border because anyway our rig will prevent liquid from pouring out. The matter is that fluid level surface behavior will look unnatural. For now, let's template this reference plane. Let's reset transformations of glass controller. And let's create a simple animation with this rig, just a test animation. Let's leave this glass steady for 15 frames. Go to frame 15 and set animation key for the translations and rotations. Now let's move this glass to the right. Note that I'm moving controller in maybe 20 frames. Set animation key. And in the middle of this range, let's tilt a little this glass and move it up. Something like this. Now let's leave this glass static for about 25 frames maybe. Set animation key. And let's tilt it to the left. Note that this rotation should be limited by this reference plane. So we should not intersect fluid level surface with glass border. So let's leave it somewhere here. Set animation key. Let's leave this glass in this position for about 25 frames again. Set animation key. And let's rotate it back again in 15 frames. Let's set playback speed to real time and let's see what we have. let's leave this test animation like this. So, as I said, we will use dynamic curve and we need to restrict fluid level surface motion to make this fluid level surface always stay in the glass volume. Actually, we need to create collision surface which will restrict dynamic curve motion. So, let's make some reference curve. Let's create the CV curve with 6 or maybe 7 vertices. Now let's center pivot of this curve and let's also move its pivot to the base using curve snapping. Let's scale this curve down. And let's also enable drawing overrides and make this curve maybe red to see it properly. Now let's point constrain this curve to the level controller. Now let's rotate this glass to the extremity, somewhere here. And this is actually a rotation limit, and virtually dynamic curve will collide with collision surface here and bounce back. Let's delete this point constraint and let's parent this curve on the level controller. Now let's reset glass transformations. Let's move this curve a little sideward to prevent intersection of collision surface with dynamic curve, but let's move its pivot back to the origin. Now we can revolve this curve and let's also set sections to maybe 16. So this will be our collision surface and we need to convert it to polygons. Let's open conversion knobs to polygons options. Let's reset settings. Let's convert using control points method. Tessellate. Let's enable polygons view. Let's check normals of this polysurface. Normals should be directed inward because dynamic curve will collide with this surface from inside. Let's also apply mesh smooth to this surface. Let's toggle off display normals. Let's name this surface collider. And let's also parent it on the level controller. And I think we can delete its history. Let's check what we have. This is revolve surface. We can actually delete it. And we have collision surface. Now we need to create dynamic curve, but first let's create separate dummy for it too. Let's create simple polycube. Let's scale it down. And let's snap this cube to the locator too. So let's select this locator, shift select this polycube and apply point constraint. Now we can delete this constraint. Let's move it a little up. Let's delete its history, freeze its transformations. Let's also name this cube hair dummy. And now we can parent this dummy on the level controller too. Now let's create dynamic curve. Let's create edit point curve with linear curve degree, snap to grid. So this is 2 vertices curve. Center its pivot and move this pivot to the base too, again using snapping to curve. I think we can scale this curve. And now let's point constrain this curve under its dummy. Select hair dummy, select this curve, constrain point. We actually need only to move this curve to its proper position. So let's delete point constraint of this curve. So here it is. Well, it looks a little messy. Let's hide surfaces for now. Let's freeze its transformations. Now let's make this curve dynamic. Let's open follicle settings and set point lock to base. Let's also hide original curve. So like this we will see only hair curve. And let's parent this follicle on the hair dummy. let's switch to the front view. And let's play back to see what we have. Let's select output curve to see its animation properly. And now we see that when glass is tilted, curve is not oriented perpendicularly to the ground. Let's open hair system settings. In Dynamics section, set stiffness to 0. Let's play back again. We can actually toggle isolate selection to see only dynamic curve. We need to increase this curve mass because now it's too light. And we can actually just set hair system gravity to 5. Let's play back again. Okay, let's toggle off isolate selection. Now we need to connect collision surface to the hair system. So let's select this collision surface. Let's also control select hair system. And in hair menu, apply make collide. Let's play back to see what we have. And we see that hair sticks to the collider. Let's increase hair system collision over samples. Let's set it to 20. And let's also set iteration of the solver to 22, just in case. Now let's select output curve and let's play back again. Now it's okay, and I think we can create hair cache for this curve. That's it. Now we can play back this hair animation forward and backward. Now let's attach joints chain to this dynamic curve. Let's hide polygons too. Let's also hide locators. So here is our curve. Let's enable join tool. And let's create two joints chain using curve snap. That's it. And now we can create IK spline handle for these joints. Let's open IK spline handle tool options. Let's reset settings. And let's turn off auto create curve because we're going to select this dynamic curve. And let's also turn off auto parent curve. So now we need to click on the first join, on the second join, and then select curve. So IK handle is created. Let's switch back to the front view and play back again to see what we have. Everything seems to be okay. Now let's create liquid level surface. We could actually create a plane, but to add some curvature to the surface, let's create Noob's sphere. Let's rotate this sphere to have this seam at the top. Let's also move this sphere pivot to the base. Now let's scale this sphere. To have this area almost flat, let's move this sphere to the liquid level a little lower because it has some curvature. And we need to add subdivisions. And I want to warn you about some issue which I discovered when I was making this rig. in the center of this liquid level surface should be a patch and not vertices. That is to say, you either should set subdivisions number to odd values, or you should rotate this sphere to make sure that you have patch in the center and not vertex. Otherwise, we will get some unpredictable trim issues. Trimmed surfaces will disappear and appear where we won't need them. Let's also check normals of this surface. We need these normals to point to the air, so let's reverse this surface. Let's reverse, for example, U direction of this surface. That's it. Now let's toggle normals view off. Let's delete history of this surface and let's freeze its transformations. Let's open outliner. Let's find this joint. And we actually need to parent this NURBS sphere. Let's name it liquid level. So we need to parent this NURBS sphere under the joint. Now let's play back to see what we have. Let's switch to front view. It's okay. Now let's build other surfaces and intersect them. Let's for now hide this NURBS sphere. Let's keep this glass for history. Let's open outliner, find it. Let's duplicate it and hide original. So we're going to work with this copy. Let's check normals of this surface. Normals are directed outward, so this will be glass surface. Let's hide normals. And we actually need to intersect on the inner part of this glass surface. So we need to detach inner volume of this glass. Let's select some isopalm, maybe here, and let's apply detach surfaces. We need to reparent this part under glass controller, and let's name them. This one will be outer glass and this one will be inner glass. Let's also duplicate inner glass surface. This will be liquid surface. Let's name it like this. And we need to reverse normals of this surface. So let's reverse surface direction. That's it. Let's toggle isolate selection and check normals of this surface. Normals are okay for this surface, so let's toggle them off. Let's toggle off isolate selection, select all these free surfaces, and let's delete history. Now let's hide outer glass surface and let's unhide liquid level surface. Now we need to intersect liquid volume with liquid level. Select liquid and select liquid level, apply intersect surfaces. And actually we're going to intersect this liquid level surface with the inner glass surface too. So for now let's delete its trim curve, its under shape, select it and delete. Well, we could create intersection curve only on one surface, but I prefer to leave default settings. Now we need to trim liquid volume, enable trim tool, and we need to select trim point carefully to make sure that it will not be passed by liquid level. Let's select this point at the bottommost part of this liquid volume. OK. Now let's intersect liquid level with inner glass. Intersect surfaces. And now we need to trim these surfaces, so select liquid level, enable trim tool, and this time we need to select trim point right at the center of this surface. Again, to make sure that it will not be intersected with the glass border. That's it. And let's also trim inner glass surface. We need to select trim point at the border of this surface, because it's supposed that liquid level will never touch this area. So select it and press enter. Now let's toggle X-ray and let's assign different material to the liquid surfaces. Blend with red tint, and let's assign same material to the liquid level surface. That's it. If we play back now, we see that due to the trim, calculation is pretty slow. So let's make play blast. So we have what we needed. After animating character's hand with glass, all you need is just select dynamic curve, toggle isolate selection and create cache for it. And after that make play blast and check if everything is okay with trimmed surfaces. So this is pretty simple trick that can make our life easier. And this is not all. Here we have constant level of fluid. We can change this level, but we will need to rebuild collision surface. And this can be a little tedious to rebuild this surface each time after changing fluid level. So in the second part of this tutorial I will show how to automate this collision surface rebuilding. And also I will show how to make this fluid surface really wavy and jiggling, because now in extreme glass rotations this fluid seems to get stuck. Plus I will show how to build proper hierarchy to easily import this rig to another scene. And another important topic is rendering. Actually, you will not be able to render this animation properly with Mental Ray, because Mental Ray has some bug with trimmed surfaces. So also I will show how to prepare these surfaces to render this animation properly. You can find second part of this tutorial on startvfxpro.com in free stuff section.